These are the video notes for Level 3 Notes, Unit 6 for the solving radical equations and equations with rational exponents. The first step we're going to do is we're going to isolate the radical or rational exponent. So what steps would you take to isolate the radical or rational exponent? First thing, see, I need to isolate this right here. What's under the radical? So I need to go out here and take, this is a positive 3, so I'm going to subtract 3 from both sides. And then over here on the left, I'm left with 2 times the square root of x minus 3 equals 8. I still don't have it isolated. I have this 2. This means 2 times the square root of x minus 3. So the inverse operation of multiplication is division. What I do to one side, I must do to the other side. My 2's cancel, and I'm left with square root of x minus 3 equals 4. We're going to look at that here in a second, what we do next. So let's work on some of these other problems. This time I have the cubed root, but the same steps. I have a negative 7. I'm going to add 7 to both sides. I get 5 times the cubed root of 6x plus 3 equals 15. This is multiplied, so I need to divide both sides by 5, and I get the cubed root of 6x plus 3 equals 3, which is what we get right here. The last one up here is one that's a little bit different. It's written differently, and so let's see if we can do this and see if it's much different. Again, I have 10 minus 2, so I'm going to subtract this 10 and move it over here, and I'm left with negative 2 times x minus 12 to the 2/3 power, and that equals to negative 2. Remember that something to the 2/3 power is really the same as this 3 is in the denominator, so it's the same as the cubed root of x minus 12 squared. So it looks much simpler like this, but if it looks confusing, that's what that means. We'll need to know that later when we solve. So now I'm going to divide both sides by negative 2. These cancel, and I'm left with x minus 12 to the 2/3 power equals a positive 1, which is what I have there. So far, I'm doing okay. Next, we need to eliminate the radical or rational exponent. So what step should we be taken to eliminate the radical or rational exponent? So right here I have the radical, square root of x minus 3. Well, if you remember from level 1, the opposite or the inverse operation of square root is squared. So I'm going to take my square root of x minus 3 and I'm going to square that. What I do to one side, I have to do to the other side. So let's write that so you remember. Inverse of square root, like the square root of x, would be x squared. So when I square this, I'm just going to be left with x minus 3. Because square root of x minus 3 times square root of x minus 3 is just going to give me x minus 3. 4 squared, or 4 times 4, is 16. So now I'm going to add 3 to both sides, and I get x equals 19. So I've solved for that right there. My next problem, I had a cubed root. So the opposite operation, or the inverse operation, of cubed root is to cube it. So let's rewrite this, and I'm going to cube it. Or raise it to the 3rd power. That means the same thing. So when I do that, I'm going to end up with 6x plus 3 here equals 3 cubed is the same as 3 times 3 times 3. 3 times 3 is 9, and then 9 times 3 is 27. You could use your calculator, but that's the basic idea behind that. So the next thing I need to do, I add 3 here, so I'm going to subtract 3 to isolate my x. I get 24. 27 minus 3. Next thing I do is divide both sides by 6, and I get x equals 4. Now this one with the rational exponent to the 2/3, remember when I said up here that it's the same as the cubed root of x minus 12 squared. You could also think of it the inverse of 2/3 is 3/2. And when you multiply those together, they cancel out and you get 1. And that's what we want to happen. So let's write it like that. X minus 12 to the 2/3 power. If it's raised to the 2/3 power, I want to raise it again to the 3/2 power. If I do it to this side, I have to do it to this side. Remember the rule of exponents? When we raise a power to another power, we multiply. So when I multiply 2/3 times 3/2, I get 1. So my answer over here on the left side is going to be x minus 12. That's why I did that. I wanted those to cancel out, so I just have x minus 12, and then I can solve for my x. Do you remember the rule that whenever you raise 1 to any power, it's going to be 1? But we could break it down like this. We could say, okay, 1 to the 1/2 power. 1/2 power means square root. Square root of 1. And then we're going to raise that to the 3rd power. That 3 in the numerator means that's raised to the 3rd power. Square root of 1 is 1. 1 cubed, or 1 times 1 times 1, is still going to give you 1. So now I need to add 12 to both sides so I can solve for my x. And I get x equals 13. Sometimes, whenever you have an equation, you may have an equation where you have like the square root of something equals that variable again. And so it's not as easy to solve like we just did. We're going to have to get all of our x's and everything over on the same side and set it equal to 0, then use the zero product rule. The things that we learn, we keep using over and over again. So you have to make sure you learn whatever we're learning time, because you will see it again. So as equations become more complex, we will use additional methods to solve. So if we have the square root of 12 minus x equals x, well, the first thing we want to do is we want to get rid of this radical, the square root. So if we square both sides, we'll eliminate the radical, and we'll have 12 minus x equals x squared. Well, now what we're going to do is we're going to set it equal to 0. So if I had it 0 here, because I have x squared there, I'm going to add x and subtract 12. I know it's kind of 2 steps at one time, but I zero out both things on this side of the equation, and I'm going to have to here subtract 12 and add x. So I'm going to end up with x squared plus x minus 12. So if you need to pause the video to think about what I just did, there was a lot of steps, you may do that, and then I'm going to keep going. Now if this looks familiar, we have a quadratic equation or a trinomial. If you have a quadratic equation, you can always use the quadratic equation formula to solve for it. But I have a trinomial, and I can go ahead and factor it if it's set to 0, and to me that is easier. My a is 1, and my c is 12. Remember, we multiplied our a times our c, 1 times negative 12, and we find the factors of negative 12, and then that's how we set up our factored equation. So I have negative 12. The factors of negative 12 are 1 and 12, 2 and a 6. I'm looking for two numbers that when I subtract them, I get a positive 1x. Then I also have 3 and 4. Ooh, 3 and 4. I have a positive x, so my bigger number needs to be positive, and my smaller number needs to be negative. So I'm going to have x plus 4 and x minus 3. That's how I factor this. So once I do that, I know that I can say x minus 4 equals 0, or x minus 3 equals 0, add 4, and I get x equals 4, or here when I add 3, this is actually plus, so it's subtract 4, sorry. I knew something was wrong there. When I add 3 to both sides, I get x equals a positive 3. So my solution set for this problem would be a negative 4 and a positive 3, which we'll see right here are our solutions. So it says check for extraneous solutions. So if I go ahead and put those two solutions in. If I say, okay, square root of 12 minus x, sorry, you can't see that, let me move it up, equals x. So let's input negative 4. Remember, this was a negative 4. So square root of 12 minus negative 4 equals negative 4. Well, first of all, can this be negative? It cannot. So this is an extraneous solution. This is not going to be a valid solution to our equation. But could I say square root of 12 minus x, which is, my other answer was 3. I'm going to just put 3 here, equals 3. Yes, this can be positive, but let's go ahead and work this out. This would be 12 minus 3 is 9. Square root of 9 is 3. So the only solution that is valid is the square root of 3. So let's work this other problem. Same concept. I have square root of 18 minus 3x equals x. I squared both sides and get this. Now I want to set it equal to 0, and so I'm going to subtract 18, add 3x, and I kind of reorder it so everything flows right. I get 0 here, x squared plus 3x minus 18. When I factor that, 1 times negative 18, my factors that when I subtract them, since this is negative, remember we're going to have x plus something and then x minus something. 1 and 18, does that, when I subtract those, do I get 3? Nope. 2 and 9, no, that would give me 7. 3 and 6, I think that's it. It's positive, so I'm going to have a positive 6 and a negative 3. Plus 6 minus 3. You can solve it like I did here, or another way is you could just say this is going to be the opposite sign. So negative 6 plus 6 gives me 0, and then over here a positive 3, 3 minus 3 gives me 0. So my solution set is negative 6, 3. Which that's what they show here. Whenever I check for extraneous solutions, remember, just like before, since this is a square root, can my square root equal a negative number? It cannot. So my only valid solution would be 3. So you have another page with practice problems. Please work on those. The best way to learn is to practice and then check your answers and see if you're getting them right. Good luck.